Now we take interest in dealing with logarithmic differentiation. Logarithmic differentiation. As an example, suppose y is equal to e power x minus y. My dear friends, I am considering one of the most standard problems. Every example which I like to quote here is a standard example. It's better to remember about the answer. Yes, it is a famous answer. How does it look? Log y is equal to x log of e power x minus y, that is x minus y into log e, but log e is 1, hence it is x is equal to y plus log y. X is equal to y plus log y. Y is equal to e power x minus y. So log y is equal to x minus 1 into log e. Log e is nothing but 1. So it is x minus y. Now we have taken logarithms on both the sides so that it is facilitated. We could have got a facility. What is that facility? The exponent part, which is in terms of x and y, has come down to the original part. You see, as now I differentiate it with respect to y rather than x. What happens? dx by dy is equal to derivative of y with respect to 1, derivative of log y, 1 by y. So it is y plus 1 by y. Y plus 1 by y. Hence dy by dx is therefore equal to y by 1 plus y. dy 1 plus y. So log y is equal to e power x minus y. So log y is equal to e power x minus y. So log y is equal to x minus y. Hence x is equal to y plus log y. Instead of differentiating with respect to x, I could have done with respect to y, thereby dy by dx is obtained as y by 1 plus y. Yes. Another famous example I like to quote. You consider y is equal to x power y, or y is equal to y power x. Both of them, y is equal to y power x or y is equal to x power y. In both the situations, our procedure is same. That is, log y is equal to y log x. Differentiate with respect to y on both, with respect to x on both sides, log y. For log y it is 1 by y. For y it is dy by dx. Now here, y log x, u derivative into v plus v derivative into u. So that this is 1 by y into dy by dx minus log x into dy by dx is equal to y by x. Our purpose is to get dy by dx. You get dy by dx out as a common factor. What can you see? dy by dx into 1 by y minus log x is equal to y by x. Multiply with y on both sides. What happens? dy by dx into 1 minus y log x is equal to y square by x, or dy by dx is equal to y square by x into 1 minus y log x. But you see, y log x is nothing but log y. You can write like this also, y square by x into 1 minus log y. So two answers. This is a famous question and famous answer also. If y is equal to x power y, then dy by dx is equal to y square by x into 1 minus y log x. How is it famous? How is it reused again? We shall now look at that. So, if y is equal to x power y, then dy by dx is equal to y square by x into 1 minus y log x. You consider the function y is equal to x power x power x power x power etc. infinitely many number of times. Then you see y is equal to x power. What is this expression? X power x power x power etc. For that we can replace it by y again. Therefore y is equal to x power y implies dy by dx is therefore equal to dy by dx is therefore equal to the previous answer, that is y square by x into 1 minus y log x. Y square by 1 by x into 1 minus y log x. So the previous answer is reused again. You see, while going through a problem or a particular question and its answer, it becomes important when it can be reused again. Simply because of that reason, the previous question and the previous answer are important. That is, if y is equal to x power y, then dy by dx is y square by x into 1 minus y log x. Yes. Let us now one more example regarding logarithmic differentiation. Observe this lengthy of function. Y is equal to ax square by x minus a into x minus b into x minus c plus bx by x minus b into x minus c plus c by x minus c plus 1. He is asking about dy by dx. At 3 junctions you may have to use u by v formula, and here it is uvw, this is uv. It's not a joke to have it in directly. Therefore, we can simplify the function, given function itself. Later on we shall differentiate. You observe this sum. What is c by x minus c plus 1? C plus x minus c. C and c will go away, leaving you x by x minus c. Correct? LCM is x minus c. LCM is x minus c. So it is c. Here this x minus c. Minus c plus c will go away. It is x by x minus c. Now again add this and this. What is going to happen? What is the LCM? X minus b into x minus c. Here it would be bx. Here it is x into x minus b. X into x minus b. What is going to happen? You observe, x into minus b is minus bx and plus bx will go away, leaving you x into x is x square by x minus b into x minus c. Again, you add this and this. Imagine, what is the LCM? X minus a into x minus b into x minus c. Here, in the first one, it is ax square, and here it is plus x minus a into x square. X into x is x square, isn't it? Total ax square minus a into x square minus ax square will go away, leaving you x cube by. So this is x cube by x minus a into x minus b into x minus c. Now we look at this y suitable to take logarithms on both sides. We can now apply the process of the method of logarithmic differentiation at this situation, but not at this situation. So if a problem like this is given, you are supposed to simplify the expression in the beginning. and it's not impossible. You can say it just within seconds in your mind itself. You need not put all these steps on paper. You can imagine directly that y is equal to x cubed by x minus a into x minus b into x minus c. And then what is its derivative? We shall now look at. This is our y. Well, take logarithms on both the sides. What is going to happen? Log y is equal to log m by n log x cube minus log of this can again be taken as for the sake of explanation only I am putting these steps, but one can easily arrive at this step directly. Log y is equal to 3 log x minus log of x minus a minus log x minus b, etc. This step is not necessary. As I told you, for the sake of explanation only I have put this step. Now this derivative can also be read directly. What is that? What is the derivative of log y? For log y it is 1 by y, and for y it is dy by dt, that is y dash. 3 log x, 3 by x. 1 by x minus a minus 1 by x minus b minus 1 by x minus c. But you see, we astonish it looking the options. No option contains this answer. Surely. Then what should you do? There is a simple calculation here. This is 1 by x minus 1 by x minus a, 1 by x minus 1 by x minus b, 1 by x minus 1 by x minus c. Do you agree with this step? 1 by x, 1 by x, 1 by x, 3 by x, it is present. Minus 1 by x minus a, minus 1 by x minus b, minus 1 by x minus c. Everything is present here only. Well, what type of benefit you are going to get? Some cancellations will be there and some simplification can be observed here. Let us look at that. X minus a minus x. X and x go away, leaving you minus a by x into x minus a plus minus b by x into x minus b plus minus c by x into x minus c. Again it can be taken as 1 by x into a by a minus x plus b by b minus x plus c by c minus x. Therefore, this is all 1 by y into y dash is equal to. Therefore, y dash is equal to y by x into a by a minus x plus b by b minus x plus c by c minus x. This will be available in the options. So, a very, very simple idea changes the shape of the answer. This is that idea. 3 by x is being written as 1 by x plus 1 by x plus 1 by x, and that each 1 by x is distributed to each of these three expressions, so that we could have got the answer like this. This is also a memorable answer. You may have to keep this in your memory. Yes, a beautiful, famous problem. First of all, it is famous. Therefore, if y is equal to ax square by x minus c into x minus b into x minus c plus bx by x minus b into x minus c plus c by x minus c plus 1, then actual simplified form of that y is of course x cubed by x minus a into x minus b into x minus c, and by differentiating it after taking logarithms, that is by using the procedure of logarithmic differentiation, we could have arrived at the answer y dash, that is dy by dx is equal to y by x into a by a minus x plus b by b minus x plus c by c minus x is the right answer. This is the problem. The next one, differentiation of inverse trigonometric functions. Differentiation in which inverse trigonometric functions are involved. As an example, suppose y is equal to sine inverse of root of 1 minus x square. If you proceed bluntly taking root 1 minus x square as x, sine inverse x derivative is 1 by root of 1 minus x square, and again like that, it takes time. You see, sine inverse of root 1 minus x square is just nothing but cos inverse x, isn't it? If you take x is equal to cos theta, what is 1 minus cos square theta? Sin square theta. Root of sin square theta is sin theta. Sin inverse of sin theta is theta. Theta is nothing but cos inverse x, provided x, the domain of x is of course to be given there. Generally he gives in such problems so that it is cos inverse 1 by x square. Hence dy by dx is therefore equal to minus 1 by root of 1 minus x square. Why? Because it has been taken as cos inverse x, isn't it? Therefore dy by dx is equal to minus 1 by root 1 minus x square. Another problem, suppose y is equal to sine inverse of 2x into root 1 minus x square. You must have enough command over formulae regarding inverse trigonometric functions and all the formulae from compound angles and multiple angles of trigonometric ratios. If you take sine theta in the place of x, 2 sine theta into root of 1 minus sine square theta, that is 2 sine theta into cos theta, it is sine 2 theta. Sine inverse of sine 2 theta is 2 sine theta. Sine inverse of sine 2 theta is 2 theta. 2 theta is nothing but 2 into sine inverse x. What I mean to say is you must be able to recollect this is the right option. Automatically, this is therefore dy by dx is therefore equal to 2 by root of 1 minus x square. Every time I am speaking, he gives the domain of x in which it is present. According to that only we shall be doing this. Unless it is given, we may have to think of the domain of sine inverse function, etc., etc., etc. Well, like that, one more thing. Suppose y is equal to sine inverse of 3x minus 4x cube is given. What do you say about it? What do you say about it? If you take x is equal to sine theta, 3x minus 4x cube, 3 sine theta minus 4 sine cube theta. What is that? Sine 3 theta. Sine inverse of sine 3 theta is, okay. Let us have these steps once. Here, x is equal to sine theta. Then, what is y? Sine inverse of 3 sine theta minus 4 sine cube theta. 3 sine theta minus 4 sine cube theta, what is that? Sine inverse of sine 3 theta. You can take it as 3 theta. But what is theta? Sine inverse x. Therefore, y is equal to 3 sine inverse x and dy by dx is therefore equal to 3 by root of 1 minus x square. Like that. So, depending on the formula on which that particular shape is dependent, from those of trigonometric ratios or compound angles or multiple angles of trigonometric ratios, you must be able to choose its suitable trigonometric ratio in the place of x so that y can be simplified, 3 by root of 1 minus x square. Cos inverse of 1 minus 2x square. Come on, recollect the formula of cos theta or multiples of theta. If you take x is equal to sine theta, what is 1 minus 2 sine square theta? Cos 2 theta. You have 4 different formulae for cos 2 theta. I think you remember. Cos square theta minus sine square theta, 2 cos square theta minus 1, 1 minus 2 sine square theta, and cos square theta minus sine square theta, isn't it? Like that. And 1 minus tan square theta by 1 plus tan square theta. So according to the shape which is suitable to this, we choose this suitable trigonometric ratio. You take x is equal to sine theta, then put x is equal to sine theta, x is equal to sine theta, then y is therefore equal to cos inverse of 1 minus 2 sine square theta. What is 1 minus 2 sine square theta? What is 1 minus 2 sine square theta? It is just nothing but cos 2 theta. Cos inverse of cos 2 theta is 2 theta. But you see theta, what is theta? Sine inverse x. This is your y. And you can read the answer, dy by dx is equal to 2 by root of 1 minus x square. It's not impossible. It is direct and simple. So, derivative is 2 by root of 1 minus x square. What do you think of in this this problem? Y is equal to cos inverse root of 1 minus x by 2. What type of formula you have with this? Say 1 plus x by 2. You imagine root of 1 plus cos theta by 2 is nothing but cos theta by 2. Therefore, you take x is equal to cos theta or cos 2 theta. Cos 2 theta. Then y is equal to cos inverse of 1 plus cos 2 theta by 2. What is 1 plus cos 2 theta? 2 cos square theta. By 2 is cos square theta. Under root it is cos theta. Hence it is theta. You see, 2 theta is cos inverse x. So this is half into cos inverse x. So dy by dx is therefore equal to minus 1 by 2 root 1 minus x square. Minus 1 by 2 root 1 minus x square. You see, if instead of plus, if minus is given, what do? It is then become sine 2 theta. Sine 2 theta is nothing but cos 90 minus 2 theta. Cos of 90 minus 2 theta. Hence it is cos inverse of cos of means 90 minus 2 theta. You see, so the answer will be 90 minus 2 sine 2 cos inverse x. While finding the derivative of 90 is going to become 0, if extra minus becomes, that's all. So nothing to worry about the sign here. Well, let us consider one more such thing. Y is equal to cos inverse of 1 minus x square by 1 plus x square. 1 minus x square by 1 plus x square. Which form is suitable for this? You take x is equal to tan theta. 1 minus tan square theta by 1 plus tan square theta. You observe. What are you having? In the place of x, we are imagining tan theta. X is equal to tan theta. Then y is equal to cos inverse of 1 minus tan square theta by 1 plus tan square theta. Cos inverse of cos 2 theta. What is cos inverse of cos 2 theta? 2 theta. That is therefore it is 2 tan inverse x. Hence dy by dx is therefore equal to 2 by 1 plus x square. 2 by 1 plus x square. Good. Not only with sine inverse and cos inverse, even with respect to tan inverse functions also, you can choose a suitable trigonometric ratio so that the given function can be simplified first and then we find its derivative. Let us look at the problem given on the board. Y is equal to tan inverse of root 1 plus x minus root 1 minus x by root 1 plus x plus root 1 minus x. Then f dash 0 is. Let's say you may have to choose a suitable trigonometric ratio to be replaced in the place of x so that you are going to get a formula in terms of tangent ratios, tan of. And as we look at, we may not be able to get an immediate idea, but there are so many ways. Number one, divide both numerator and denominator by root of 1 plus x square, 1 plus x, and put x is equal to cos 2 theta. Put x is equal to cos 2 theta. Then what happens? 1 minus tan theta by 1 plus tan theta, that is tan pi by 4 minus theta. Direct. Another way, you rationalize it, both the denominator, and you put x equal to sine theta. There are so many ways. And the other way is Put x is equal to cos 2 theta. What is y? Tan inverse of root of 1 plus cos 2 theta root of 1 minus cos 2 theta root of 1 plus cos 2 theta What is root of 1 plus cos 2 theta? It is root of 2 cos square theta, root of 2 sin square theta, root of 2 cos square theta, root of 2 sin square theta, and root 2 can be cancelled in both numerator and denominator, so that you will be having tan inverse of cos theta minus sin theta by cos theta plus sin theta. Cos theta minus sin theta by cos theta plus sin theta. Now you divide it with cos theta on both numerator and denominator. What happens? 1 minus tan theta by 1 plus tan theta. Tan inverse of 1 minus tan theta by 1 plus tan theta. Okay, what is 1 minus tan theta by 1 plus tan theta? It is nothing but tan inverse of tan of pi by 4 plus theta. 1 minus tan theta by 1 plus tan theta. Good. This is pi by 4 minus theta. Theta. What is theta? 2 theta is cos inverse x, and hence it is half into cos inverse x. 2 theta is cos inverse x. So theta is half cos inverse x. This is your y. Hence, what is this f of x is equal to f dash x is therefore equal to minus half into minus 1 by root 1 minus x square. It is 1 by 2 root 1 minus x square. You just take 0 in the place of that. What are you going to get? It is half. Hence the right option is. My dear friends, what I mean to say is you can directly come to this position or this position directly. These steps can be observed in your mind itself. Such a simple way it is to use those steps. Such simple steps they are. You can imagine in your mind. You need not use pen and paper. You can directly come here so that it is pi by 4 minus theta. Hence the answer is this. So by calculating in the mind itself, will be minimizing the time to spare, of course. Therefore, the right option is C. The right answer is half. One more thing, y is equal to tan inverse of 3x minus x cube by 1 minus 3x square. On this part itself, you can tell me the answer. You need not put any steps here. By taking, of course, x is equal to tan theta, you will be having 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. What is that? Tan 3 theta. Tan inverse of tan 3 theta is 3 theta. That is, its derivative is 3 into theta is tan inverse x. Tan inverse x derivative is 1 by 1 plus x square. Hence it is 3 by 1 plus x square. Like this, you can have the answers directly whenever simple trigonometric, inverse trigonometric functions are given, in which the substitution of a trigonometric ratio in the place of x gives you the standard formula, can be simplified like this. Well, y is equal to root of x plus root of x plus root of x plus root of x plus etc. 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 Now we are switching over to deal with the next model. With the next model, that is whenever a repeated function has been given, whenever a problem in which the function has been repeated and repeatedly, infinitely many number of times. You observe this function, root of x plus root of x plus root of x plus root of x plus etc. 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 What is derivative? Now, This is nothing but y is equal to root of x plus y. Root of x plus y again, because we close this. What is this? Again y is square on both these sides. Y square is equal to x plus y, or y square plus y is equal to x. That is, now you differentiate it on both sides so that you have 2y plus 1 is equal to x. I'm sorry, it is minus into dy by dx is equal to 1. Hence, dy by dx is equal to 1 by 2y minus 1. So this is a beautiful procedure. Let us now let us now design a beautiful structure, a rather beautiful formula which can be reused again. For that purpose, I like to create this problem. Y is equal to root of f of x plus root of f of x plus root of f of x plus root of etc. infinitely many number of times. Absolutely in the similar fashion as before, you square it on both the sides and differentiate every step is similar. Come on, do it. Y is equal to root of f of x plus y. Square it. Y square is equal to f of x plus y. So, y square minus y is equal to f of x. Differentiated on both the sides, 2y minus 1 into dy by dx is equal to f dash x. From that, dy by dx is equal to f dash x by 2y minus 1. In this problem, in the place of f of x we have x. F dash x is 1. That is why it has become 1 by 2y minus 1. With the help of that particular one, we will be able to give the answers for so many such questions. How? Look at that. Y is equal to square root of x cube plus square root of x cube plus square root of x cube and so on. Suppose you have. Then what is dy by dx? What are you having? In the place of f of x, we have x cube. Its derivative is 3x square. Hence, it is 3x square by 2y minus 1. One more problem. Y is equal to square root of e power x plus square root of e power x plus square root of e power x. Like that, infinitely many number of times. Come on, what is the answer for dy by dx in this case? F of x in the place of f of x, what are you having? E power x. So it is e power x by 2y minus 1. Like that. Shall we have one more such problem? Why not? You take y is equal to root of log x plus root of log x plus root of log x plus etc. infinitely many number of times. Come on, what is dy by dx? F dash x, f of x is log x, f dash x is 1 by x. Hence the answer is 1 by x into 2y minus 1. 1 by x into 2y minus 1. Therefore, to answer all these questions, what answer could help us? This answer is helping us. If you have a function of this form, then dy by dx is f dash x by 2y minus 1. In the previous model, we have y is equal to root of. If you have cube root of, or fourth root of, in that way, in that situation, what should you do? Very simple. Let us have one such structure. Y is equal to nth root of f of x plus nth root of f of x plus nth root of etc. Like that. In this case, we have y is equal to nth root of f of x plus y. Take whole power n on both the sides. Y power n minus y is equal to f of x. Differentiate on both the sides. We have dy by dx is therefore equal to f dash x by, what is the derivative of y power n minus y? n into y power n minus 1 minus 1. Let us now use this to answer this. Y is equal to fourth root of sin x plus fourth root of sin x plus etc. infinity. What is dy by dx? I like to have the answer. Come on. What are you having in the place of f of x? Sin x you are having. Its derivative is f dash x is cos x. Hence the answer is cos x by n is 4, isn't it? Y power 4, the derivative of y power 4 is 4y cube. 4y cube minus 1. Not only sin x, whatever f of x whose derivative is known, that can be given there. That is which is differentiable. Yes, like this. So the previous answer and this answer can be reused once again. That is why they are to be remembered. They are to be remembered. Next one. Y is equal to x plus 1 by x plus 1 by x plus 1 by x plus 1 by etc. etc. In this case, what do you do? I want dy by dx. It's very simple. It is of course a continued fraction which can be extended to so many number of times. Y is equal to x plus 1 by y, isn't it? X plus 1 by x plus 1 by x plus 1 by. Multiply both sides with y. What do you have? Y square is equal to xy plus 1. Y square is equal to xy plus 1. Or y square minus xy minus 1 is equal to 0. Let me call this f of xy. From this we have dy by dx is therefore minus fx by fy. What is its derivative? By taking x as the only variable, 0 minus y by its derivative by taking y as the only variable is 2y minus x. So dy by dx is therefore equal to y by 2y minus x. Y by 2y minus x. You see, you need not use this formula. You can directly differentiate on both sides. Of course, y square is 2y into dy by dx is equal to xy, means 1 into y plus x dy by dx. And we're getting dy by dx to one side. You can have the answer also. That's what I mean is, that is also simple. 2y into dy by dx is equal to uv. Come on. U dash v plus v dash u. Taking dy by dx is a common factor. Dy by dx into 2y minus x is equal to y. Dy by dx is therefore equal to y by 2y minus x. As you like it, you can use whatever formula you like, whatever procedure you like to have, you can use. That is, this is in the shape of a continued fraction, isn't it? Okay, one more such thing. Y is equal to e power x plus e power x plus e power x plus e power etc. 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 What do you do? Similar procedure. Therefore, y is equal to e power x plus y. Take logarithms on both the sides. Log y is equal to x plus y into log e. But log e is 1. Log y minus y. Dx by dy is equal to 1 by y minus 1, 1 minus y by y. Or dy by dx is y by 1 minus y. So, the way of attacking is important. Yes, this is the crucial step. You can apply whatever method you have in your hand, you can use it to have the derivative. Well, let me have one more such thing. This is nothing but y is equal to x power y. You might have recollected it. It is a beautiful formula. This has already a background. This is dy by dx is equal to y square by 1 minus y log x, isn't it? The same format, the same formula is reused here. Hence dy by dx is equal to y square by 1 minus y log x. Rather than this, if you have y is equal to root x power like that, then what happens? Y is equal to root x power y. Square it on both sides. Y square is equal to x power y. Y square is equal to x power y. Again 2 log y is equal to like that. Isn't it? Take logarithms on both sides and get it differentiated, you will have the answer. So if at all you come across a function like this, you simplify like this. It is a must. While dealing with the methods of differentiation, there is another milestone in the process of differentiation called successive differentiation is there. Let us now observe the salient features, only salient features of this successive differentiation, because in so many problems in JEE and advanced level also, we will be coming across those problems in which successive derivatives, second derivative, third order derivative, fourth derivative like that, or nth derivative may also occur. Yes. What is meant by successive differentiation? Suppose y is equal to f of x is a function. Then dy by dx is f dash x. Even this is also a function of x. It might be differentiable. If it is differentiable, then its derivative is d square y by dx square, that is f double dash x. What do you mean by d square y by dx square? It's nothing but dy dx of dy by dx. Even this is a function of x. If it is differentiable, its derivative again can be found as d cube y by dx cube is equal to f triple dash x. Even if this is a function of x, it can be differentiable. It can be differentiable. If it is differentiable, then its derivative again d power 4 y by dx power 4 is equal to f power 4 of x. Very dangerous and important precautionary measure that you have to take here is you have to put this symbol. Then only this symbol represents the fourth derivative of f of x. Unless or otherwise, there may be a danger of assuming the function to be f of x whole power 4. Yes, there are some others and there are some lecturers, there are some students also who can understand this f power 4 of x as f of x whole power 4. To avoid such danger, to avoid such misunderstanding, a particular way of symbolism has been introduced, put like that, f power 4 of x. That is fourth derivative of f of x. Like that, if we proceed, d power n y by dx power n is equal to nth derivative of x. My dear friends, this is a must to represent this small and within small brackets. Then only we mean it to be the nth derivative of f of x. Well, this is a theoretical part only. In particular, symbolic part only. There are some more symbols. This dy by dx is now and then written as y1. This is written as y2. This is written as y3. This is written as y4. This is written as yn, like that. What do you mean by yn? What do you mean by yn? It's nothing but the nth derivative of y. And some others also use the fn to mean the nth derivative of f. This is the symbolic part of differentiation, the successive differentiation. Let us now observe some results and formulas, types of procedure like that under this heading. Consider the function y is equal to ax plus b whole to the power of n. What is y1? What do you mean by y1? It is just nothing but the first derivative, that is dy by dx, that is n into ax plus b whole to the power of n minus 1 into, what is the derivative of a? What is the second derivative? Derivative of first derivative, n into a into n minus 1 into ax plus b whole to the power of n minus 2 into derivative of this. Come on, what is y3? You need not find it again, you can trace it. What is that? N into n minus 1 into n minus 2 into a cube into ax plus b whole to the power of n minus 3, isn't it? Now you imagine, I like to write this as np1 a power 1 ax plus b whole to the power of n minus 1. This as np2 a square ax plus b whole to the power of n minus 2. This is np3 a power 3 ax plus b whole to the power of n minus 3. And in general, yr, what is yr? npr a power r ax plus b whole to the power of n minus r for all 1 less than or equal to r less than or equal to n. If r is equal to n, what happens? npn and factorial a power n into ax plus b whole power n minus n, that is 0. Therefore, yn is equal to n factorial into a power n. It has become a constant now. Yn is equal to n factorial into a power n. What is yn plus 1? That is, if you want to differentiate it still after n times, that is the n plus 1th time, it becomes 0. So n plus 1th derivative of y is therefore equal to 0. Now this is reusable as, now I like to ask you one question. Y is equal to 3x whole to the power of y is equal to x to the power of 5. What is the fifth derivative? In the place of a, we have 1. In the place of b, we have 0. In the place of n, we have 5. Come on. It is y is equal to x power n. In the place of n, we have 5. Why 5 I am asking? It is 5 factorial. It is 5 factorial. Well, I like to have y3. What is that? np3. 5p3 into x power 5 minus 3. That is 2. What is 5p3? 5 into 4 into 3. That is 20 into 3. 60 x square. Isn't it? First derivative is 5x power 4. Next is 20x cube. Next is 60x square. Correct. So 5p3 into x square. And in general, suppose y is equal to 4x plus 1 whole to the power of 10. What is the 11th derivative of y? 0. Why is it? Whole power n is 10 only, and we are asking to have, we are asking the 11th derivative, so it is automatically 0. Well, for this function, can you tell me what y3 is? Surely 10p3, 4 power 3, 4x plus 1 whole to the power of 10 minus 3. What is 10 minus 3? 7. That is the third derivative. This is the very first form of nth derivatives. I mean the successive derivatives. Yes. Therefore, y is equal to ax plus b whole to the power of n implies yr is equal to npr into a power r into ax plus b whole to the power of n minus r for all 1 less than or equal to r less than or equal to n. That is the formula that must be put in our mind. Well done. We enjoy the very first formula of successive derivatives. There are beautiful formulas. You see, the number of formulas or the number of applications is so limited because derivability repeatedly may not occur at so many number of times, at so many number of functions. There are few functions whose nth derivatives may exist. Therefore, there are only limited number of formulae for this. One more thing we like to observe is y is equal to 1 by ax plus b, or is its derivative. To have the derivative successively for this function, you may have to recollect a beautiful formula from derivatives. That is a derivative of that you must recollect. Derivative of 1 by x power n is minus n by x power n plus 1. Everybody knows about it. Well, now you think of this as some x. What is the derivative of 1 by x? Minus 1 by x square. Minus 1 by x square into a. Again, y2. You forget minus 1 and a. 1 by ax plus b whole square is already minus 1 is here. 1 by x square. What is derivative? Minus 2 by x cube. Minus 2 by x cube, that is ax plus b whole cube into one more a. Already one a is there, so it is a square. Again, this is nothing but 2a square by ax plus b whole square. What is y3? Imagine 2a square is in the denominator and 1 by ax plus b whole square, its derivative is minus 2y. I'm sorry, it is a cube. 1 by x square derivative is minus 2 by x cube, isn't it? Like that. Now, extra minus 3 is going to come in the denominator, so that it is minus 6a cube by ax plus b whole to the power of 4. What is y4? Minus 4 comes extra. 24a power 4 by x plus b whole to the power of 5. By observing all these, what is yn? Yn is equal to, what I mean to say is nth derivative is y1 negative, y2 positive, y3 negative, y4 positive, y5 negative, like that. Yn, who knows about n? It is minus 1 whole to the power of n. If n is an odd number, that is ordered derivative, that is third derivative, minus fifth derivative, minus first derivative, minus some, we are taking minus 1 whole power n. In the first derivative we have a, the second derivative we have a. Just a minute. Let us now concentrate on the numbers. In the first derivative we have 1, second derivative 2, that is 2 factorial. Third derivative we have 6, 3 factorial. Fourth derivative we have 24, that is 4 factorial. And in the nth derivative we have n factorial into a power n by ax plus b whole to the power of the first derivative we have square. In the second derivative we have whole cube. In the third derivative we have whole power 4. And in general nth derivative we have n plus 1. N plus 1. Therefore, phi is equal to ax plus b. Then yn is equal to minus 1 whole power n into n factorial into a power n by ax plus b whole to the power of n plus 1. Well, this is the next result we should remember so that it can be reused. Let us observe 1 or 2 applications for this. We have 1 by x plus 1. I want the fifth derivative. Come on. Fifth derivative means no doubt it is minus 1 whole power 5. n factorial, that is 5 factorial. 5 factorial into a. For a we have only 1. So it is 1 power n by x plus 1 whole to the power of 6. That is minus 120 by x plus 1 whole to the power of 6. Again, it is y is equal to 1 by 2x plus 3. I want to have the 10th derivative. What is that? 10 is an even number. Minus 1 whole power 10 is positive. Into 10 factorial into a power n, that is 2 power 10 by 2x plus 3 whole power 10 or 11. Why? Because we have whole power n plus 1 in the denominator. Well, y is simply 1 by x. I want to have yn. What is that? Minus 1 whole power n into n factorial by x to the power of n plus 1. That is a very simple and straight application of that formula. It's a beautiful result. The second result from successive derivatives. Next, the third one. If y is equal to log of ax plus b, then what is the first derivative? 1 by ax plus b into a. First derivative is positive. What is y2? Minus 1 by ax plus b whole square into a square. Isn't it? y1 is 1 by ax plus b into a. y2 is minus 1 by ax plus b whole square into a square. y3 is 2 by ax plus b whole cube into a cube. y4 is minus 3 by, so it is minus 6 by x plus b whole to the power of 4 into a power 4 and so on. Fourth derivative, 6 I am having, 3 factorial. Third derivative, 2 factorial. Second derivative, 1 factorial. First derivative, 0 factorial. So what is the number which is present in the numerator of the 10th derivative? N minus 1 factorial, isn't it? It is n minus 1 factorial. Therefore, yn is equal to n minus 1 factorial into, say, the key point that must be kept in mind here in these problems is n minus 1 factorial is occurring, therefore minus 1 whole power n minus 1 occurs in the beginning. Why? Because the derivatives are odd-ordered derivatives are positive and even-ordered derivatives are negative. You can observe that. First derivative, positive. Third derivative, positive. Fifth derivative, positive. Second order derivative, that is y2, negative. y4, negative. y6, negative. In order to save that, in order to preserve that concept, we put minus 1 whole power and minus 1 in the numerator. And the remaining things are very simple. As usual, a power n also becomes in the numerator. Observe the denominator. First derivative, ax plus b. Second derivative, x plus b whole square. For third, it is whole cube. For fourth, it is whole power 4. For nth derivative, it is whole power n. Whole power n. So, ax plus b whole to the power of n. The three important and reusable nth derivatives are like this. There are three more: sine of x plus b, cos of x plus b, e power x plus b into e power x plus b, like that. Now, if y is equal to e power x plus b, one of the simplest and important things it is y1 a e power x plus b, y2 a square e power x plus b, y3 a cube e power x plus b, y4 a power 4 x plus b. So, e power x plus b, no changes at all, isn't it? Therefore, yn is equal to a power n into e power x plus b. This is the next one. Yes, of course. What is y1? E power x plus b into a. y2? E power x plus b into a square. y3? E power x plus b into a. Like that. yn is a power n into e power x plus b. Well, two more things are there. Y is equal to sine of ax plus b and cos of ax plus b, and e power x plus b into sine of bx plus c, e power x plus b into cos of bx plus c. Like that. Three more results are there. Let us now quote them. You consider these two functions at a time, that is y is equal to e power x into sine bx plus c and y is equal to e power x into cos bx plus c. They behave in a similar way in view of results and formulas. Look here, dy by dx is, if you want to have just the derivative of that, you are supposed to have the uv formula, and it can be taken by taking a is equal to r cos theta and v is equal to r sin theta. The simplification becomes very simple, so that it is r into e power ax into sine of bx plus c plus theta, where theta is tan inverse b by a. Similarly, dy by dx is therefore equal to r into e power ax into cos of bx plus c plus theta, where theta is equal to tan inverse b by a and r is equal to root of a square plus b square. And its proof is can be made very simple if you take in terms of in the place of x, you imagine a complex number. Yes. And r is equal to root of a square plus b square. You see, you observe the first derivative and the nth derivative. D power n y by dx power n is equal to r power n into, that's all the change that comes here, sine of bx plus c plus n theta, that is n tan inverse b by a, where r and n stand for the same. Okay, and similarly here it is d power n y by dx power n is therefore equal to where theta is tan inverse b by a and r is root of a square plus b square. How similar they are, just in the place of sine function we replace cos function, that's all. These are the nth derivatives of these standard functions, e power ax into sine bx plus c, e power x into cos bx plus c, like that. With the presence of e power x, those two formulae take this form.